For a century, extreme speed had a distinct voice, the mechanical violence of internal combustion. Now, that roar competes with the high-frequency whine of electric power. Horsepower numbers alone do not create these vehicles. A true supercar emerges from a highly specific formula of racing lineage, ultra-luxury materials, and engineering exclusivity. In Italy, this formula prioritized aesthetic emotion. Italian manufacturers treated the automobile as a sculptural object, designing machines that were intended to be experienced as rolling, drivable art. This obsession with passion over utility began in the grandstands. Enzo Ferrari sold road cars to fund his racing ambitions, deliberately controlling supply to create a culture of artificial scarcity. That same exclusivity triggered its own opposition. A successful tractor manufacturer named Ferruccio Lamborghini grew frustrated with the Italian racing elite and built his own V12 Grand Tours in defiance of Maranello. Across the Alps, Germany approached performance with an entirely different methodology. Their engineers extracted emotion through repeatable mechanical perfection, utilizing rear-engine layouts and flat-six engines that could sustain high speeds on the Autobahn without failure. These early combustion machines were physical extensions of the cultures that built them, fracturing the global supercar market into competing regional philosophies. Britain lacked the massive engine displacement favored by continental Europe. To compete, they focused on removing mass. Lotus founder Colin Chapman established the doctrine. He recognized that eliminating weight from a chassis improves acceleration, braking, and cornering, allowing a small engine to outrun a larger one on a track. Decades later, engineer Gordon Murray applied this exact logic to the ultimate road car. He rejected heavy four-wheel drive systems and oversized components in favor of strict weight reduction. The result was the McLaren F1. By pioneering a central driving position and a carbon fiber monocoque, it weighed significantly less than its competitors while reaching 240 miles per hour. Mastering lightweight materials gave small British workshops a mathematical advantage, neutralizing the immense V12 and flat 12 engines produced by their European rivals. Developing carbon fiber monocoques and bespoke engines requires immense capital. Today, the image of the independent national manufacturer is largely a carefully maintained illusion. Behind the aggressive Italian styling of modern Lamborghinis lies a corporate reality. The brand is owned and funded by Audi. Audi itself is a branch of the Volkswagen Group. This German conglomerate controls the engineering budgets for Porsche, Lamborghini, Bentley, and the Bugatti Rimac venture. This consolidated ownership enables platform sharing. Vehicles marketed as fierce national competitors utilize the same underlying chassis architecture and proprietary software development. The structure repeats across the industry. Stellantis dictates the direction of Maserati, while the Chinese giant Geely provides the capital keeping Lotus alive. For these conglomerates, a boutique supercar brand does not need to generate billions in direct sales. The exotic vehicles act as high-visibility brand builders that elevate the prestige of their parent company's everyday consumer cars. The modern battle of national automotive pride is orchestrated from the boardrooms of a handful of multinational mega-corporations. A few manufacturers refuse to integrate into this European corporate matrix. To survive independently, they adopted highly specialized engineering tactics. The United States relied on brute force. Ford proved this approach at Le Mans in the 1960s, deploying massive V8 engines to overpower European finesse. Japan bypassed traditional displacement. Their engineers relied on complex algorithms and advanced sensor arrays to make speed repeatable. With the GTR, Nissan utilized twin-turbocharged power and an intelligent all-wheel drive system to analyze traction in real time, matching European exotics at a fraction of the cost. In Sweden, Koenigsegg bypassed the traditional gearbox entirely and replaced cam-driven valves with pneumatic actuators. By rewriting the physics of the drivetrain, they remained competitive against giant corporate budgets. Surviving outside the conglomerate umbrella demands ideological extremism. Whether through American muscle, Japanese computing, or Swedish mechanical invention, the outsiders break the established rules. The defining characteristic of the supercar is changing. The mechanical violence of the combustion era is giving way to the efficiency of high-voltage electric power. For a century, the barrier to entry was the specialized metallurgy and mechanical tolerances required to build a reliable V12. That expertise takes decades to master. But in the electric era, performance is dictated by battery chemistry and software code, industries where Croatia and China possess a global lead. By leveraging vast battery supply chains and massive manufacturing scale, these new players are building vehicles that achieve acceleration numbers previously thought physically impossible for road cars. This diagram shows how torque vectoring has become the new metric of control. Software calculates and distributes power to 4 independent electric motors instantly, adjusting grip wheel by wheel. Paired with active aerodynamics that adjust downforce, these digital chassis execute dynamic maneuvers that mechanical linkages simply cannot replicate. By replacing engine calibration with softmind logic, electrification makes raw acceleration accessible. The engineering quest to extract a few more horsepower from a gasoline engine is now technically obsolete. This technological leap poses a question. If a family sedan with electric motors can reach 60 miles per hour in under 2 seconds, what is it that makes a supercar special? Internal combustion engines generate immense heat, vibrate, and require the driver to manage a narrow power band, creating a tactile experience. Electric platforms eliminate those mechanical flaws, but silence makes it difficult to justify a multi-million-dollar price tag based on performance data alone. The supercar is currently moving away from being a hardware challenge and toward being an emotional one. The next century belongs to the nation that prioritizes the visceral response of the human driver over the data on the stopwatch.